Hi, this is Dr. B.K. Parthiban, working as an assistant professor in the Department of Mechanical Engineering at Kamraj College of Engineering and Technology. In this video, we are going to discuss on the topic kinematic chain and degrees of freedom. Now, let us start with the term kinematic chain. Kinematic chain is nothing but the combinations of kinematic pairs in a condition that the first link must be connected with the last link. So, that is the definition. When the kinematic pairs are coupled in such a way that the last link is joined with the first link to transfer the motion, the motion may be a completely constrained or successfully constrained, then the arrangement is known as kinematic chain. Now, let us discuss the various types of joint which we are using in our mechanism structures. So, the kinematic chain, in a kinematic chain, the joints are classified in three types. First one is binary joint, second one is ternary joint, and third one is quaternary joint. Let us consider this is link 1 and this is another link. Link 1 and link 2 are going to be connected. So, here this joint is made between two links. When two links are joined at the same connection, then this joint is known as binary joint. So, in this 4 bar mechanism, this is link 1, this is link 2, this is link 3, this is link 4. Link 1 and link 2 are connected at a point A. This point A is known as binary joint. Similarly, this link L1 and L2 are connected at this point. This point is also known as binary joint. Let it be named as binary joint A, binary joint B. Similarly, it is also having binary joint. This connection is also having binary joint. In the same manner, if we are adopting three links L1, L2 and L3 are connected in a connection, then the joint is termed as ternary joint. So, when three links are joined at the same connection, then it is known as ternary joint. So, in this case, at the point E, link 4, link 5 and link 6 are connected. So, this is known as ternary joint. Whereas, in case of point A, link 1 and link 6 are connected. So, this is known as binary joint. Similarly, when 4 links are combined, this is link 1, let it be link 2, let it be link 3, let it be link 4, then this connection is said to be quaternary joint. So, in this diagram 1, 2, 3, so this is ternary joint, whereas point G is a quaternary joint because link 7, 8, 10 and 11, 4 joints are connected. So, now we have come across the various types of joint in kinematic chains. So, binary joint which having connected by means of 2 links, ternary joint connected by 3 links, quaternary joint connected by means of 4 links. The next one is we are going to calculate the total number of binary joint for a given mechanism. So, let it be a 4 bar mechanism and this point is B1, B2, B3, B4. Now, we are going to calculate the total number of binary joint. As we said earlier, the link 1 and link 4 are connected. So, this is known as a binary joint. Similarly, link 2 and link 1 are connected at a one point. So, this is also a binary joint. Link 2 and 3 are connected at B3. This is also a binary joint. Similarly, link 3 and link 4 are connected at one connection, then it is known as binary joint. So, in this given arrangement, we are having 4 binary joint. So, the total number of joints is nothing but 4. Now, let us go for the another example. So, link 1, link 2 connected at this point, this is B2 represents here binary joint. Link 2, link 5 and link 3 are connected at this point. So, this is T1. T1 is an example for ternary joint. Similarly, in this arrangements we are having 1 binary joint, 2 binary joint and 3 binary joint and 1 ternary joint and 2 ternary joint. So, on the analysis of this arrangement, we came to know that we are having 3 binary joint and 2 ternary joint. However, we are supposed to find out the total number of binary joints. So, that we have to make one convention. The convention is 1 ternary joint is equal to 2 binary joint. So, that the total number of binary joint in the given kinematic arrangement is 3 binary joint plus 2 ternary joint. Now, I am going to apply this equation. So, that this 2 ternary joint can be rewrite as 2 into 2 binary joint. So, it will use 2 into 2 is 4, 4 plus 3 is 7 binary joint. The total number of binary joints in the given structure is 7. Okay. I have proved that this arrangement is having 7 binary joint. Similarly, let us have another example which is having a 9 different links. So, this is binary joint 1, binary joint 2, ternary joint 1, ternary joint 2, but here we are having quaternary joint. Quaternary joint is nothing but we are going to have 4 different link connection at a single point. So, let us cross check link 3, link 7, link 8, link 4. So, 4 links are connected at a single point, then we will term as quaternary joint. So, that in this arrangement we are having 2 binary joint, 2 ternary joint and 2 quaternary joint. As I said earlier, there is a conversion for ternary joint to binary joint. Similarly, there is also a conversion factor for quaternary joint also, and the conversion factor is 1 quaternary joint is equal to 3 binary joint. Now, apply this formula. So, we are having 2 binary joint, we are having 2 ternary joint and 1 ternary joint is equal to 2 binary joint. So, it will becomes 2 into 2 and we are having 3 quaternary joint. So, 3 into 2. By applying this formula, we are having total 12 binary joint. Binary joints is nothing but simply joints. So, in this arrangement we are having 12 binary joint. As of now, we have learnt about what is mean by kinematic chain and how to calculate the number of joints in a given arrangements. Now, we are move on to the next important topic, degrees of freedom. Degrees of freedom is also known as mobility. In simple words, degrees of freedom is not defined as the number of input parameters which may be controlled in an independent manner to bring the mechanism into a useful work, or to do any converting any mechanism into a work, we have to give an input. So, how many number of inputs are required to control the mechanism, then it is known as degrees of freedom, and it is possible to determine the degrees of freedom based on the number of links and number of joints which are present in that kinematic arrangement, and it is denoted by n. Mathematically, we are having a formula to calculate the degrees of freedom, and the degrees of freedom is calculated by using the Kuchbach criterion. As per the Kuchbach criterion, the degrees of freedom n is equal to 3 into L minus 1 minus 2j minus h, where L represents number of link, J represents number of binary joint and H represents number of higher pair. Now, let us solve problems to calculate the degrees of freedom. Number of link, let us solve the first problem. In problem number 1, the number of links is link 1, link 2, link 3, link 4, link 5. So, we are having 5 links, and let us make an joint analysis. So, joint analysis means we have to identify the binary joint, ternary joint and quaternary joint. So, link 1 and 2 are connected. So, A, link 2 and 3 are connected B, 3 and 4 are connected C, 4 and 5 are connected D, 5 connected with again 1. So, in this problem we are having 5 different joints, and all these finds are comes under the category of binary joint. Now, substitute in this formula, n is equal to 3 into 5 minus 1 minus 2 into 5, where J represents binary joint, J represents binary joint minus higher pair. So, in none of the case higher pair is present. So, 5 minus 1 is 4, 4 into 3 is 12, minus 10, minus 0. So, in this case n is equal to 2, which means it requires 2 inputs to convert this arrangement into a mechanism for doing a useful work. That is the meaning. Now, let us solve the next problem. Again the same thing, we need to find out the degrees of freedom by using Kuchbach relation, n into 3 minus 1 minus 2j minus h. Now, this problem. So, this is considered to be link 1, link 2, 3, 4, 5, 6. So, the total number of link is 6 in this case, and the very important thing is joint analysis. First of all, let us give the number for all the intersection connections. So, 1 is connected with 2, let us make it as A. Similarly, 2 is connected with 3, let it be B. Then this is C, D, E, F, G. Now, let us make a joint analysis. This is link 1 is connected with link 2. So, the point A is nothing but a binary joint. B, link 2 and link 3 are connected, that is also a binary joint. Point C, in point C, link number 3, link number 5 and 3 and 5 only connected. So, point B is also a binary joint. D, 5 and 6 are connected, that is also binary joint. Point E, link 1 and link 6 is connected, that is also a binary joint. Point F, link 1 connected with link 4. At point F, link 1 and link 4 is connected, that is also a binary joint. And point G, similarly, it is also a binary joint. There will be no ternary joint and no quaternary joint. Here the count is 1, 2, 3, 4, 5, 6, 7. Now, substitute in the formula, Kuchbach criterion 3 into L minus 1, here the value for L is equal to 6 minus 2 into 7 minus 0. So, 6 minus 1 is 5, 5 into 3 is 15 minus 14 minus 0. The value for n is equal to 1, which means it required one input to form this arrangement into a mechanism. This is the literal meaning for this calculation. Now, let us go for the last problem. This is the last problem. L 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, 11 links. It is considered to be a one link. Okay. Now, we are going to make a joint analysis. 1 and connected with link 2, this is A. 2 is connected with 2, 4, 5, this is B. Next this one C. Again C with 1, this is D. This is E, F, G, H, I, J, K. So, we are having connections up to K. Now, let us make a joint analysis. Point A is connected with 1 and 2, this is a binary joint. Point B is connected with 2, 4 and 5, so this is a ternary joint. C is connected with 4, 3 and 6, so this is also ternary joint. The next one D is connected with 3 and 1, so it is binary joint. Next one is E is connected with 5, this entire arrangement is 7 and this one is 8. So, 5, 7, 8, this is ternary joint. Then F 6 and 7, G is connected with 7 and 1, so it is a binary joint. H is connected with 9 and 7, binary joint. I is connected with 8, 10 and 11, so this is also a ternary joint. J is connected with 9 and 10, so this is binary joint. K is connecting with 1 and 11, so this is also binary joint. So, in this case we are having 1, 2, 3, 4, 5, 6, 7 binary joint and 4 ternary joint. While determining the degrees of freedom, we have to convert all the joints into binary joint. So, we have to convert this ternary joint convert into binary joint. We all know that one ternary joint is equal to 2 binary joint, that means it is equal to 8 binary joint. Now, substitute in this formula, n is equal to 3 into level minus 1 minus 2 into 7 plus 8 is 15 minus 0. So, 11 minus 10 is 11 minus 1 is 10, 10 into 3 is 30 minus 2 into 15 is 30 minus 0. So, in this case n is equal to 0. So, in one case we have determined n is equal to 2, in one case n is equal to 1, in one case the n is equal to 0. N is equal to 0 means this arrangement is not able to convert into mechanism whenever we give a input also. So, this is known as structure. So, this kind of arrangements are known as structures. So, I hope you have learnt the concept of kinematic chain and degrees of freedom. Thanks to all.